It's it's a lovely Sunday morning, so we're going to analyze this neural net. I did one last live stream, and that one was kind of hard to figure out actually, but I think we're building up aptitude in figuring out these neural nets. So, yeah. So that's what we'll do. We have the novelty in this one that I trained the same neural net from different initial weight initializations 3 times. So we have like 3 different implementations of the same function. And, you know, so like that will, if we can understand what it's doing, then it will produce neural net nirvana. So that's what we're going for. So, yeah, alright, we'll just kind of hop into it. The other thing is I was playing with weight decay, so there's, like, originally, like, I think it's better to, it's not clear it's good to have weight decay because, it makes the weights, like, small. But, anyway, so, like, this is the function. It's, you know, and it's probably, you know, it's probably a little fruitful to, kind of try to, you know, like, if I were a neural net, or more particularly, if I were gradient descent, how would I implement this function, you know? That's kind of what we're trying to get a feel for. So, yeah, do I even have anything open? Yeah, okay. Yeah, this was the old one. So we're done with that. Okay, so I'm just gonna write out the red rows, right? So it's like, also to be clear, like, red color is like +1, blue is like -1, so, you know, like when you multiply a blue by a blue, you get a red. So, okay, so we're gonna write out the accept set. So this guy, right, we're gonna write out the reds. So this is like -1. Nah. Should I use zeros or dashes? They're both terrible. Oh, you know, it's, if you use a mono space, okay, okay, my computer's too slow to, I should probably buy a new computer. Yeah, so I need like some mono space. Do you have any mono space, bro? I need like some mono space. No, it's not gonna, what's a mono, oh, like consoleless. That's always good. Right? Yeah. Did that actually, okay, that didn't change anything. Okay. You know what, we're just going to ignore that for now because this was not a, okay. Let me just write this out. Okay, -1 -. 1 -. And finally 1 -1. Okay. So the problem that gradient descent is solving is it has to separate. Come on, man, seriously, I need consoleless, dude. Okay, that looks a little bit better. And then, like, make it bigger. Very cool. Very cool. Right, so like the problem that gradient descent is solving is it's trying to separate these 4 points from like every other point using dot products. And you know, so it's kind of like you know, is there anything obviously that these points have in common that is like different from all of the other points? I think obviously is that, you know, the top 3 are all Hamming weight 1, if you're into the whole Hamming weight scenario. So yeah. It almost seems like you could... I mean, this might be linearly separable. But anyway, it seems like if... Yeah, so... Well, let's just see what the neural nets do, right? You know, I mean, that's why we have them. That's why we have neural nets. So, yeah, so we'll look at the first column here in layer 2. That's actually layer 1. I mean, that's the first, like, yeah. The labels are bad. Okay, let's look at the weights for that. So we're looking at this row, and you know, it's got like red, blue in the middle, which to me says, it's basically saying, I mean, also not to be too distracted, but like in the next layer, you know, all of the weights are the same sign pattern. So that kind of indicates, I think, this function might be linearly separable, meaning like we could implement it with a single neuron. But anyway, so what this is saying is like, it's basically saying like if on the input point, it's looking for that those 2 dimensions are unequal, because if they're unequal, then these 2 points will I think dominate the output. But if they are not equal, no, if they are equal, if they are equal, these 2 inner things will cancel each other. And then I guess like the outer 2, but then also like if the outer 2 are unequal, then the bias will dominate. Yeah, so let's just look at that in action. So we're looking at the first column, which corresponds to that weight vector. And, right, so, yeah, it just produces like a big red chunk. Yeah, so let's look at all those reds. So like this chunk, they are equal in the middle too. So that means that they cancel. So that means that the outer 2 dominate. So like this row is red because you have 2 reds on the outside. These 2 rows are red because of the bias, right? Because you have this red blue in the middle, and then you have red red on the outside. Yeah, and by the way, those are all red outputs. So, right. And then, yeah, and then the other red is this row, and it's a red blue in the middle, which matches the sign pattern. Whoops. So that's why that one's red. Right, like, so, like, they're all red, but for different reasons. Like, this is red because the sign pattern dominates. This this one is red because of the outer two and the bias. And these two are red purely because of the bias. But then, like, you're picking up some other ones that, you know, you don't actually want to pick up. So, like, these are red because of the inner two is equal, the outer two are unequal, so the bias makes them red. And these are red because of the red-blue pattern. This one is red because of the outer two. Okay, so that's what that unit is doing. It's just saying, like, yeah, it's just looking for the middle two columns, and it's saying, like, if they're unequal, then the middle two columns dominate, and if they're equal, then the outer two columns dominate, unless the outer two columns are unequal, and then it's the bias. That's, you know, looks like a perfectly... Okay, so anyway, let's go to the next column. Let's look at the weights, because it's kind of hard to eyeball what it's doing here. You know, you don't want to speculate. Yeah, that one's kind of rough to look at. It kind of, I mean, it's like it's favoring the middle column, or this column. But then it also has a pretty significant bias. So it's kind of hard. Yeah, I mean, in many ways, this is the fundamental problem with, like, interpreting neural nets, because, you know, like, I mean, effectively, we're trying to transform dot products into, like, logical expressions. But that's fine. Everybody likes doing that. What if we kind of just interpret this as, like, a majority? It's just saying, like, how closely do you match blue, red, blue, ignoring the magnitudes, right? Because it's only picking out 4 points. So blue, red, blue, blue, red, that's 3, red, blue, that's 3, blue, red, blue, that's 3, blue, red, blue, that's the exact sign expression. So, like, are there any that are close but are not red? I don't know. But for the purposes of the function, I think for the purposes of computing the function, like, I think we can already compute the function, because the reds are red, blue on the first 2 columns, or red. And yeah, you can separate red, blue, like on the 2-dimensional hypercube. You can, yeah, I mean, you can separate that linearly. So, right. Okay, so okay, yeah, so let's ignore the rest of the columns. I mean, that's not necessarily what the neural net is actually doing, but we want to cache these 2 columns out as, like, a logical expression. And I already forgot what the first column. but I mean, like the high level expression is red blue on the first two columns or red red, right? Oh, actually no, that okay, you have these guys. Never mind. Never mind. Never mind. That yeah. I mean, you could maybe do it based on magnitudes, but I don't like using magnitudes. They are impure. So, I mean, also they're hard to calculate with, so. Well, let's see. Like, yeah, like, are there any two columns that we could actually use? Maybe the first and the third? No. Yeah, let's briefly think about what this layer is doing. Because it is correctly computing the function, like, in all of the columns. But it's easier to, I mean, the outer two are the negation. And that's more difficult to think about, so we'll think about, say, like, the second column. And, yeah, like, what are its weights? I think it's just, yeah, it's just a majority. It's just all red. Does that accurately? Yeah, so it's saying, like, if you're a red output, you have roughly 3 out of 4? 3 out of 4 reds. And then all of the blues are 2, 1, 1, 1, 1, 1, kind of 2. So it's just doing majority. So that's effectively what the neural net is saying. It's saying if you're a red, you have a majority, you have at least 3 out of the, actually exactly 3 out of the 4 features. Except for this guy who's kind of a wild card. I mean, that's basically 0. Yeah, okay, so we're trying to remember what all the features were. So this column is like, it's concerned with the equality of the middle 2 columns, let's say. And then I completely, this column was like majority. This column was how far away are you from blue, red, red, blue. So it's like a distance scenario. Is there any other input that, like, because this is blue, red, red, blue. This is 1 away. This is 1 away. This is 1 away. I mean, there's gonna be others. Like, blue. I feel like there should be others that are equally far away. Because you have to have at least 4 that are 1 away. Anyway, okay, let's go to the next column. Next column, this one is separating like 6 of the inputs, plus a 0. And it's all blue with no bias. So it's kind of doing a majority thingy, I guess. Kind of, so it's saying like 2 away from all blue, 2 away from all blue, 1 away from all blue, 3 away, 2 away, 1 away, 1 away, 3 away, 4 away, 2 away, 2, 3, 1, 2, right. Okay, so it's kind of doing a distance thing from all blues. Okay, and then like the last column, what's the last column? god. It's like, yeah, so it cares about red, blue, red. Oh, dang, I already forgot. Red, blue, space, red. So it's like red, blue, space, red. That one matches exactly. Red, blue, space, red. Red, blue, space, red. Okay. Red, blue, space, red. Right. Okay, so, let's, okay, like, if we look at the, right, so, like, the logic of this neural net overall, again, is like, you agree with 3 out of 4 of the features if you're a red, and no other input agrees with 3 out of the 4 features. So it's kind of like, can we intuit that? Or is it just a, it's just a thing that's true, but it's not necessarily something you can intuit. Okay, so let me build up the features again. First feature is like, are the middle 2 things equal? And are the outer 2 things equal? And it's red for all of the reds, but it also picks up a lot that aren't red. Yeah. Right. Cause why is it like picking these up? Because of red blue. It's picking these up because of red blue. Why is it? It's picking these up because of cancellation. Right. Okay. And then the next feature was distance from blue, red, red, blue. Kind of. And, like, none of these are close to blue, red, red, blue. Actually, that's kind of a good parsing, because the accept set is like, you have a negation pair, like, you have 2 points on opposite sides. Like, you have red, blue, blue, red, and blue, red, red, blue. Nope, I read that wrong. Never mind. Anyway, distance from blue, red, red, blue. Which, yeah, like, picks this guy up. It's basically the only thing that column is doing is picking this guy up. Because it's mostly blue. And then this column was, how blue are you? And like, this accept set is blue, 3 blues. 2 blues, 3 blues, 3 blues. That's a good distinguishing feature. Because, okay, that's one coherent thing we can say about the accept set. Is that all of the points have at least 2 blues. They have 2 or 3 blues. So that's kind of an important feature. I mean, there's obviously other points. There's all these points up here that also have 2 to 3 blues. But yeah. And then, can you... Right. Okay, then anyway, the last one. Oh. The last one is like, I don't care about the middle, the third column. Is there a reason it doesn't? Yeah. We can see that because all of the except set has a blue at that column. I mean, it's not really clear why that would matter, but or like why you would make that a 0. Yeah, so then it's looking for red, blue, space, red. Red, blue, space, red. Blue, space, red. Red, blue. Red. Okay, so like they all have a lot of red, blue going on. Except for this guy who's a blue, red. Right. Yeah, I mean... Right. I mean, basically this is saying, like, okay, you are in the conjunction of the first 3 features, and that's a unique point, or you're in the conjunction of the other 2 features. Right, so let's try to parse that out. Let's try to parse this one guy out. So it's saying, like, I already forgot again. Right, okay. It's saying, like, the middle 2 disagree, and the outer 2 are both blue. I mean, that's uniquely, I mean, that, yeah, okay. And, you're distance 1 away from blue, red, red, blue. And that already uniquely identifies this point. But we need 3 out of 4, so then it's like, and I don't remember what that one was. And you have at least 3 blues. And you don't match red, blue, space, red. Right. Right. Trying to figure out, like, if there's a subset of these features that would be more, that, like, because, like, if there were only 2 columns that you could use, then it would be easier. to understand. Yeah, it kind of seems like I don't see any just two columns. Yeah. I mean, you might be able to use 3 columns, but kind of incoherent at that point. Okay, so yeah, alright, let's just go through that again. It's like, yeah. This guy is red because he has unequal middle 2, but equal outer 2. You know, whereas like these guys are red because they have equal inner 2, equal outer 2, bias, right, yeah, these two are because of bias. I mean, that's like a weird, but anyway, I mean, that pulls in like a lot of blues. And then, right, that one's distance from blue, red, blue. So he's close to blue, red, blue. Whereas these 3 are not close to blue, red, blue. These 3 are very far away. Okay. And then this guy has 3 blues. This guy, all of the except set has 3 blues. Yeah. And then the last function was, yeah, the whole red, blue, space, red thing. Okay, right, so I mean, the overall logic, I'm not sure it's, like, human comprehensible, but it's just saying, like, we have these 4 features, and you're red if you have 3 out of the 4 features. Otherwise you're not red. And those features are, like, concerned with the agreement between the middle 2 columns, the outer 2 columns, and then they're just also concerned with, like, distance from this one point, blue, red, blue, distance from the all blues, and then, yeah, whatever that feature is, right. Okay, so we're gonna switch to, it's the same function, different implementation. Alright, so, but this is, wait, is this actually the same function? Yeah, right. Yeah, that's the same function, okay. This will be better because, like, we're more familiar with the function now. And, yeah. This layer seems to be very concerned with Hamming weight. So let's look at the weights. Yeah, like, so the first column, it doesn't care about the third, like, this is saying, you know, like, we only need 3 features. And, and then it's because it's correctly computing the function at this column, it's saying we're gonna have 3 features, and you're going to be red if you don't have 2 of the features, and you do have 1 of the features. I guess that's basically what it's saying. And those 3 features are, you know, how many, it's your Hamming weight basically, like, it's all red. This one also has this weird feature, this red blue space red feature, because this one also had that red blue space red. Why does it care about red blue space red? I don't understand. I don't understand that one. This one is also kind of similar to the other feature because it's concerned with the equality of the middle 2 columns and also the equality of the outer 2 columns. Yeah, so I mean, it's basically saying, like, you can almost just read it off of the weights, right? It's just saying, like, you're gonna be red if you're not close to the all reds weight vector, modulo some magnitude issues, which may or may not actually matter. And then you're also, you know, you don't have the feature of yeah, I mean, that's like a hard feature to put into words. And then also, you do have this red blue space red feature. Okay. Let's look at the red blue space red feature. So that's, where are we? So this is the last column. So this is the red blue space red feature. And red blue space, yeah. So, okay, so that's just picking out these 2 guys. But the output wants that to be red. Yeah, so that feature is, oh, but it goes to 0. It hurts on this 1, elsewise it goes to 0. Yeah, because the output is saying, like, I want these 2 columns to be blue, and I want this column to be red. So, like, these are red because both of these columns are blue. These are all blue because you have red blue. You have more red blue. And then you have you have a blue and a red, I guess, and then like a 0, and then you have 2 reds. Right. So right, so like these 2 columns are basically yeah, well, yeah, it's using a 0, so right, so I mean, this guy is like red for a different reason than these guys. This guy is red because you have blue-red here, I think. Yeah, like it's matching the blue-red, and then the other reds are matching the red-red, by which I mean blue-blue. Okay. Alright, yeah, so let's just try to think, let's try to turn that into a logical, like if you're blue here and you're blue here, what does that mean? It means that you're far away from the all reds. Let's confirm that. Yeah, like you're far away from one. These all have one red each. Okay, so you're far away from the all reds. Now this guy, this other red is like 2 and 2, like halfway. So he gets like a 0, basically. And then if you're blue over here, what does that mean? That mean, oh, yeah, that's this annoying feature. Wow. I don't know how to turn that feature into like a easy expression. It's just saying like, it's just saying if the middle two columns are unequal, then like that dominates the output. Elsewise, if the outer two columns are equal, that dominates the output. Elsewise, the bias dominates the output. It's kind of hard to put, like, it's kind of hard to put that into words, though. Yeah, we're trying to figure out, okay, we want this to be blue and this to be blue. So we know these are blue because they have a, you know, they're far away from all reds. And then these are blue because, yeah, I mean, it's the same as the other thing. Like, you have equality here, so it cancels. And then you have inequality on the outer two. So this is the bias. And then, but this one, like, anti-matches. You have inequality. So this is because of that. You have inequality there. And, this guy, you have cancels, and then bias, right? It's like, that's actually bad. You have blue-red down here. Blue-red cancels, and then you have blue-blue. Okay. Right. So, but then it's saying, like, every other, like, blue output, like these are all kind of, yeah, I mean, like, this is almost perfectly the Hemingway sort. And, right, so it's saying, like, yeah, so, like, that vector is, like, tagging these guys. Yeah, that's why it's hard to interpret. This vector is, like, super hard to interpret. But, yeah, the conjunction of those two features gives you the red. Or, like, the negation of the conjunction of those two features. Yeah, not sure, I'm not, yeah. I'm not gonna be able to parse that out. Alright, I'm just gonna briefly look at the other weights. Again, this is like the same function. I'll just look at the other weights. So they also, yeah, I mean, they all kind of favor the second column. This is that same feature. This is like the blue-red thing, and then the outer two. And then you also just have distance from constantly blue. And, yeah, and then you're saying, so like, so the first column here is correctly computing the function, so it is caring about being red, blue, space, red, being red, blue, space, red, which is like one of the features in the lower level on the other thingy. Red, blue, space, red, yeah, like they're all, yeah, red, blue, space, red, right, red, blue, space, so it's mapping everything to red, blue. So this red, blue, space, red is saying like, you're a red, it's saying you're a red if you're far away from blue. If you don't have this feature, and also you're far away from blue. Because, I mean, like, these two outer columns are the same function. And they're saying, like, right, so it's saying, like, you're close to blue. These are all close to blue. But, right, so this is saying these two features actually uniquely identify the function. And it's just saying, yeah, I mean, like, yeah, this is mapping the entire except set onto one point in these two dimensions. Yeah. So it's just saying the thing that these four rows have in common is that they're close to blue and they have this, so this is like blue, red, and then two outer blues. Wait, am I messing this up? What was I over there? No, okay. Blue, red, like, so blue, red cancels, two outer blues gives you red. Blue, red anti-controls blue, red, so that gives you negative. Blue, red bias, these two completely cancel and give you the bias. Right. So it's also saying, like, the accept set is all the points that are close to blue. Again, like, all of these are close to blue. But, because, like, all of these guys have blue, red, blue, red, blue, red. Yeah, or the blue, blue becomes red. Right. Yeah. Okay, well,